In Module 3, we're going to discuss graphs. In this chapter, we're going to define what is a graph, what are the different graph models, okay? And we're also going to discuss some terminologies about graph and special types of graphs, and what are representation of a graph, and what is graph isomorphism, and some connectivity and Euler's and Hamiltonian paths. Somehow we already discussed Euler and Hamiltonian paths in AI, if you still remember, when we are discussing the different algorithm that involves graphs. Okay, so that's one application of Euler's and Hamiltonian paths in graph. Okay, so for this session, we're going to focus on graphs and graph models. Okay, so specifically, introduction to graphs, graph taxonomy, and graph models. So let's define first what is a graph. So based on our book, a graph G is equal to vertices edges, consists of non-empty set V of vertices or nodes, and a set of E of edges. So if you're going to relate vertices to a real world scenario, a good example of that will be the cities. Okay, so locations, different locations, or modules if you're going to talk about software. Okay, so how about edges? It's basically the connection between these vertices. So if you're going to relate it to cities, this could be roads that connects our cities. So that will be edges. Okay, so in this example, we have 4 vertices, which are A, B, C, and D. And this line are called edges. Okay, so we have 4 vertices and 5 edges for this graph. Okay, so that's the definition of graph. We have vertices and we have edges. Okay, and we have different types of graph based on the edges that we have. So one is simple graph, second is multigraph, and third is pseudograph. If say simple graph, each edge connect 2 different vertices and no 2 edge connect the same pair of vertices. So we only have one connection between vertices. A good example of this is this graph. Okay, so we have one connection between AB, we have one connection between BC, we have one connection between AC, we have one connection between D and B, and we have one connection between D and C. So this is considered as simple graph. Okay, but in case we have multiple connection, multiple edges between vertices, we call it multigraph. Okay, so this is an example of multiple edges wherein B and C are connected of these 2 edges, first edge and second edge. Same as with A and C, one connection, another connection. Okay, so again, to consider a graph as multigraph, we have multiple edges, okay, between vertices. Okay, and we have another term we called loop. So if we say loop, an edge that connects a vertex to itself. So this is an example of a loop wherein an edge connect the start is vertex B and ends with vertex B. That's a loop. Okay, and if you're going to have a graph that includes loop, multiple edges, we called it pseudograph. Okay, so the difference between multigraph and pseudograph is pseudograph has loop, multigraph doesn't have a loop. Okay, so that's the difference between the two. Again, just a summary. Simple graph, we only have one connection, one edge between vertices. Multi-graph, we have multiple edges between vertices. And pseudo-graph, multiple edges between vertices and a loop. Okay, so that's pseudo-graph, multi-graph, and simple graph. Okay, now let's define what is a directed graph. If say directed graph, it is an undirected graph or digraph, G equals to VE, consists of non-empty set of vertices and a set of directed edge. So it means that we have a direction. There is a start vertex and last and endpoint vertex. So that will be directed graph. If say undirected graph, we don't have any no direction. This is an example of a directed graph. Okay, so between A and B, we have an arrow going to B. That's a directed graph. So we have two types of directed graph, simple and directed multigraph. Okay, definitely simple. It's a combination of one connection and we have a direction. While multigraph, directed multigraph rather, we have multiple connection, multiple edges, and we have a directed edges. Okay, so this is an example of it. Okay, so from B to C, we have two edges rather. A and C, we have two direction. And for the loop, we should have a direction. Start with B, going to B, start with C, ends with C. Start with C and then end with C. That's a loop. Okay, so that's simple directed graph and directed multigraph. Okay, so one application of graph is basically creating a network, computer network. So definitely in computer network, especially in the internet, we need to connect different cities, different countries. Those cities will be our nodes and the connectivity will be our edges. Okay, definitely in computer network, we don't have the connection is not just one connection, but multiple connection between cities. To ensure there is a connection, even one of the edge is been destroyed or disconnected, still we have other path. Okay, so that's one of the application of multi-graph. Okay, having multiple connection that will ensure the connectivity between cities. Okay, so that's one application of multi-graph in a real world scenario. And also one of the thing that we studied in networking, we need to check, we need to diagnose the connectivity. Okay, so one is having a loop within your vertex. Okay, so that's one application of loop. And definitely if you're going to include loop on your multi-graph, we're going to have a pseudograph. Okay, so that's one application of pseudograph in real world. Okay, and last, definitely in networking, we have two different direction. We have upload and download. So we have different connection path. So that's one application of directed graph. So in network, we have directed pseudo graph or directed multigraph if we're not going to consider the loop, since loop will be used as for diagnostic link lang naman. Okay, so that's one application of a graph. So graph is actually adopted or applied in real world scenario, and we could somehow represent a real world scenario using a graph model. So as CS, it is one of our work. Okay, in creating a graph, that will represent a real world scenario. So most of your um, some of um, m- um, some of your courses will deal with this type of problems. Okay, advanced CS courses. Now, so let's have a summary between the different graph: simple graph, multi-graph, with direction and without, and multiple edges allowed and loop allowed. Okay, so we could have mixed graph. If say mixed graph, there is a directed and undirected edges. So for this, we could have multiple and we could have loop. Okay, and the rest you know now. So kindly read the table. Okay, some other application of graphs will be social network. So this is one example of social network is definitely Facebook. Okay, so we are connected through Facebook with our friends. Communication network. So for example, our Messenger or Viber. Okay, information network. Mm. And software design. So there are some how we design it based on modules, based on function. So we could actually the black diagram is considered as a graph. Okay, and transportation network. So for example, our LRT, MRT, or railway station, or um, our airplane. Okay, and biological network like the different proteins, the different viruses. Okay, how they are related. Okay, so that's one example. That's one application of graph. Okay, so there are lots of lots of application for graph. Okay, so for social network, okay, so specifically we could create a friendship graph. So again, this is seen in Facebook. Okay, collaboration graph if you have works. So this graph will show which among these people have work with or they have collaborated in a certain work. Okay, influence graph will determine who implements who. Okay, so this is an example of a friendship graph in Facebook. It gives us an idea who are directly connected with each other, the levels of friendship, who are the who are our common friends, okay, and others. Okay, and for the influence graph, it will give us an idea who implements who. So for example, Brian influenced Linda while Brian is influenced by Yvonne. And also Brian influenced Yvonne and Brian is influenced by Deborah and Fred. Okay, and this is an example of collaboration graph, Hollywood graph. Okay, so this gives us an idea of act, who are the actors collaborated in certain films. Okay, so how they are connected through their works, through their films, through their yeah, through their works. And academic collaboration graph means if you are a scientist, if you're doing research, so definitely that research will um, be done by a group, and those group members probably will be a group of another research team. Okay, so through that we could have academic collaboration graph. Okay, and we also have the citation network. So if you're familiar with Scopus, so it will give us a idea which are the different article, different researchers that are connected based on their citation. Okay, based on the references. And for the transportation graph, we have the airline, the airport. Okay, so definitely it will give us an idea how to go to another destination, how many flight do we have, that many flights consider as multiple edges to connect, okay, as with the to connect the different vertices, the different cities. Okay, the road network, it's not just the primary road or the highway. We also have the secondary, the tertiary road that connects different location. Okay, so that's an example of a graph again. And for the software design, so what I have stated earlier, you could create your design based on modules or based on processing. Okay, those are example of a graph. Okay, if you're using block diagram, each boxes or each rectangle represent a certain vertex, and the connection between those boxes are edges. So in this example, the design is based on modules or based on functions. Okay, and we have directed path or directed edges to determine if we're going to process something, and based on a certain scenario, where will it go? Okay, which function will be next, or which module will process the data next? Okay, so that's software design application of the graph application in software design. Okay, and also for if and else statement, we could create a precedence graph. So dependent with the um, previous value, previous scenario to determine what will be the next, what will happen next. Okay. And also we have a biological application. So it will, so in this example, the hierarchy of food chain, not the hierarchy, but the food chain in a certain ecosystem. So it will determine who eats who. Okay, and the connection between proteins, the variation, which, okay, variation of what protein, how they are related. So in this example, we have RRP43, which is connected to RR42, 41, 4. So we could say that they are on the same, okay, on the same family based on this graph. Okay, so that's all the application of a graph. So on the next video lecture, we're going to discuss some terminologies and special type of graph. So thank you for listening. If you have some questions, kindly send me a message. Thank you.